question 5. So question 5 says simplify fully, and then gives us a lovely complicated fraction with a lot of different things going on. So simplify fully in terms of fractions should be an indicator to us that we're going to have some sort of common factors, maybe on the top and the bottom of the fraction, that will divide in, that when we maybe factorize some of these different terms that we might end up with the same things in different brackets, and that we should be able to simplify it down to maybe like one term or one expression. So the best way to approach these questions is to go smaller rather than going bigger. So when we're simplifying it, we want to make it into a simpler form rather than making it into a more complicated form. So let's just take a second to look at the different parts of this quadratic. So if we start off with the x squared minus 9. X squared minus 9 is a difference of two squares, which we've seen in the first part of the question, or in the first question I mean, and it can be written as x plus 3, x minus 3. Okay, underneath that we have a quadratic. We can solve that quadratic, you can solve it off to the side, you get 2x minus 5, you get x minus 3. Okay, we should see even at this stage why it's worth taking this time to go through the parts of these fractions. If we look on the left hand side or on the right hand side, x squared plus 3x, all that we can do here is factor out an x, but still worth doing. And underneath then we have 4x cubed minus 10x squared, so what I can take out there is probably a 2x squared, left with 2x minus 5. Okay, so let's just rewrite this sum, and I'm going to take this time as well to change from that dividing to a multiply. So what that means is I'm going to have to flip the second fraction. So on the right hand side, or on the left hand side, x plus 3, x minus 3. Underneath it then we have this orange term from the quadratic, which was 2x minus 5, x minus 3. Then I'm going to flip my fraction as I said. So on the top I'm going to have the blue part, the 2x squared, 2x minus 4 minus 5, and I have then the x on x plus 3. Okay, so now we're going to take a minute to look at what different terms maybe can we engage with a little bit. So say the x minus 3, x minus 3 here, so we can see we have an x minus 3 on the top, we have an x minus 3 on the bottom, so those will divide in. Over here then we're going to be multiplying what's on the left by what's on the right. So I have an x plus 3 on the top here and an x plus 3 on the bottom here, so again they will divide in nicely. Here as well I have a 2x minus 5 and a 2x minus 5. So really all I'm left with is 2x squared over x, which simplifies down to just 2x, and that is my answer. So the key thing there is to take that first little step, try and factorize all of those different parts, simplify them down as best you can, and you will generally find that some of them will have common factors that will divide in nicely and make the sum a lot easier for you. When you're simplifying, we should end up with an answer that's going to be simpler than the one that we started with. That's generally the goal. For the next part, find the range of values of x for which 3x minus 2 over x minus 5 is less than or equal to 5. So to do a question like this, we have a lovely fraction on the left hand side. Generally with a fraction we want to eliminate the bottom part of the fraction, and to do that we would multiply both sides by what's on the bottom. However, here we have a kind of added, I suppose, complication, which is the inequality sign. And what it means is that we have to multiply both sides by x minus 5 squared. So on the left hand side I'm now left with x minus 5 by 3x minus 2, and on the right hand side it's 5 by x minus 5 squared. Here, the reason we're only left with one x minus 5 on the left hand side rather than the squared is because we have the one on the top that we multiplied by, and we had the one on the bottom that was there already that we were trying to eliminate. So on the left hand side I now get 3x squared minus minus 15x minus 2x plus 10 is less than or equal to 5 by x squared minus 10x plus 25. Okay, again, just multiplying this out or tidying up a little bit here. So 3x squared minus 17x plus 10 is less than or equal to 5x squared minus 50x plus 125. Okay, at this point, I want to get everything onto one side. So I'm going to bring everything over to the right hand side here. That's going to leave me with 2x squared. I'm going to have minus 33x plus 115. And I'm just going to take this minute, I suppose, to maybe flip the sum around a little bit just so it looks the same as we're used to. So all I've done is I've taken it from one side and I've just flipped it around the other way. So keeping the inequality pointing towards the 0, so that it's still that the quadratic is greater than or equal to 0. So we take our quadratic, we let it equal to 0. We have 2x squared minus 33x plus 115 is equal to 0 because we want to solve it. Okay, solving that quadratic will give us that x is equal to 23 over 2 and x is equal to 5. Okay, then we have to remember that when we've done these questions before, we've had to draw a little diagram for ourselves to tell us where we're looking at. So this is my quadratic here. My two roots are 5 and 23 over 2. And from this part of the question, we should be able to tell which part of my graph or my diagram or my little sketch that I'm looking at. And it's going to be these two end parts. It's the parts that are above the x-axis because it's greater than or equal to 0. We're saying where is this graph, where is this equation, where is this function greater than or equal to 0? And that is those two end parts where it's above the x-axis. So what that means for us is that x has to be less than or equal to 5 and x has to be greater than or equal to 23 over 2. Now what we do have to look at here is to do with the 5, because we were told at the start of the question that x is not equal to 5. So what that means is that instead of saying less than or equal to 5, we're going to have to just say less than 5. So still greater than or equal to 23 over 2, but less than 5, because x is not allowed to be 5. And that's to do with the fraction in the initial question. So that's our answer then. X is less than 5 and x is greater than or equal to 23 over 2. The last part of this question asks us to prove that the equation has real roots and hence or otherwise write down the roots. So let's focus on the first bit first. So we need to prove that it has real roots. We should remember that real roots means b squared minus 4ac is going to be greater than or equal to 0. So that's for real roots. So greater than or equal to 0. So let's take this. So b 2, p plus 1. Being careful here as well that we don't accidentally take the question down wrong. Okay, so it's minus 2p plus 1. It's not minus 2p, it's minus bracket 2p plus 1. Now when we square that, obviously that will eliminate the minus for us anyway. So we get 4p squared plus 4p plus 1 minus 8p greater than or equal to 0. I get 4p squared minus 4p plus 1. Okay, at this point we're still questioning, is it greater than or equal than 0? 4p squared minus 4p plus 1 is an example of a perfect square, and we can rewrite it as 2p minus 1 all squared. And that is greater than or equal to 0, because anything squared is greater than or equal to 0. So we've proven that it has real roots. Has real roots for all values of p. So real roots for all values of p. Then to write down the roots of the equation, we're going to have to use our minus b formula. So minus 2b plus 1 plus or minus the square root of b squared minus 4ac. Now b squared minus 4ac is exactly what we've done on the left hand side here, so we can maybe just take a little bit of a help from that side, I suppose, to save us doing it out again. So I'm going to have 2p plus 1 plus or minus 2p minus 1 all over 2p. So x is equal to 2p plus 1 plus 2p minus 1 over 2p, which is 4p over 2p, which is just 2. Or it's going to be 2p plus 1 minus 2p plus 1 over 2p, which is just 2 over 2p, which is 1 over p. So we have that x is equal to 2 or x is equal to 1 over p. And those are our two answers in terms of p, as we were asked. So we were asked to give our answers in terms of p, and so then it's fine that we have one answer being 1 over p. So with that one there, I suppose the first thing is making sure that you're happy with those questions of the nature of the roots and using the discriminant, and that b squared minus 4ac is greater than or equal to 0, and proving that on the left hand side. That's often the way that those inequality proofs will come up. And then on the right hand side, it was just finding the roots of that equation. And I suppose just making sure as well that you don't forget that part. Okay, it could be easily missed in the question.